So a number is said to be rational. And the rationals are denoted by the letter Q. The number is said to be rational. It can be written if it's possible to write it as a divided by b, where both a and b are integers. Positive and negative and zero whole numbers. And of course, b can't be zero. So 7/5 is a rational number. So this is rational. Or we can write 7/5 is in Q. We said Q denotes a set of rational numbers. And just like when we're talking about the natural numbers or the whole numbers or the integers, we put a double bar down the left-hand side. So Q is the set of all rational numbers. And this little symbol right here, which I'm almost certainly going to write again, this little E looking thing, that just means in. So 7/5 is in the set of rational numbers. In other words, it's a rational number. The number 1.2 is a rational number because I can write 1.2 as 12 divided by 10. If you type this, if you do the division, you type that in your calculator, 12 divided by 10 is 1.2. 0.5 is a rational number. That's the same as 5/10, or in lowest terms, 1/2. So these are all examples of rational numbers. Not, well, let me say one more thing about rational numbers. So the decimal expansion, if I expand a rational number, so if I write it as a decimal, decimal expansions of rational numbers either terminate so these terminate, they stop 1.2, and then after that's just zeros. 0.5, that just stops. After that, it's just zeros. Those are terminating decimals, so they either terminate or repeat. So it's possible to have a decimal which repeats and still be rational. If I take the decimal expansion 1/3, that's 0.33333 forever. That repeats forever. Sometimes people write that as 0.3 with a little dot over the 3, or sometimes a little bar over the 3. That just means it keeps repeating forever. If I give you something like 0.121212 going on forever, that is a rational number. This repeats forever, and we can write that as 0.12 with a bar over the top of the 1 and 2. Just means the 1 and the 2 and the 1 and the 2 go on forever. So these are also examples of rational numbers. They either terminate or repeat forever. Not all numbers are rational numbers. You can write examples of numbers whose decimal expansions don't repeat forever. So for example, you've almost certainly seen some of these in the past. The number pi, which is a little bit bigger than 3, it's 3.14. Maybe you were asked to memorize part of this in some class at school, 1, 5, 9, 2, and then it just keeps going. But it does not repeat forever. If you take the number square root of 2, the number that when you square it, you get 2. This is also not a rational number. This is about 1.4142828, and then it keeps going on, but it does not repeat forever. So these numbers are not rational numbers. So we could write pi is, you take the symbol for in and you put a bar through it, that means not in. Pi is not in the set of rational numbers. Neither is the square root of 2. Okay. Let's talk about equivalent fractions. We've already seen some equivalent fractions. We know that 5/10 is the same thing as 1/2. We saw that over here. What we do when we get a fraction in lowest terms is get all the common factors out. So the 10 we talked about in the last video, we can factor that. This is 5. We can factor 10 as 2 times 5. And you can cancel out things on the top and the bottom. When you cancel out this 5 with this 5, it leaves a 1 on the top. When you cancel, it doesn't leave a 0, it leaves a 1. If everything is canceled, it leaves a 1. When you divide 5 by 5, so on the bottom, you've divided 10 by 5 to leave 2. And on the top, you've divided 5 by 5. That doesn't give you 0, that gives you 1. So this is the same thing as 1/2. So when we're getting a fraction in lowest terms, what you want to do is get rid of all the common factors. So if I give you something like 8/12, we can factor the top factors. Let's do this as 2 times 4, and 2 times 4 is certainly 8. And the bottom we know is 2 times 6. We can cancel the 2's. So we're left with 4/6. That looks like we might be able to go down even a little bit further because we can factor the top again as 2 times 2, and the bottom is 2 times 3, and we can divide these 2's out and you end up with 2/3. So 8/12 in lowest terms is 2/3. So you can get a fraction in lowest terms by canceling out all the common factors from the numerator, the top, and the denominator, the bottom. So numerator and denominator are just fancy words for the top and the bottom. Numerator, denominator. That's fancy words for the top and the bottom. I'm perfectly happy with the top saying top and bottom, but you should recognize what somebody's talking about when they say numerator and what they mean when they say denominator. So how can we go back and forth between decimals and fractions? One direction is pretty easy. If I take so if we want to go from a fraction to a decimal, for example, 3/4, that's just a matter of long division. You can type this into your calculator if you want. You can take 3 divided by 4. I'm going to do it sort of by hand. 4 goes into 3. 4 doesn't go into 3 anytimes. But if I put a decimal after that and some zeros, 4 goes into 30. We know 7 times. 7 times 4 is 28. 28 away from 30 is equal to 2. We can bring down the 0. 4 goes into 20. 5 times 4 is 20. 20 minus 20 is 0. That's it. So we have 0.75. Might have been a very, very long time since the last time you did a long division. I am not trying to necessarily get you to do long division. I just want you to realize that that's all that's happening here. Going from a fraction to a decimal, whether you do it on a calculator or do it out longhand, is just long division. What about going the other way around? What about decimal to fraction? There's just a little bit more work, especially if we want to get the fraction in lowest terms. So the first thing that you should recognize is that it depends on whether or not the decimal terminates, like it did over here, or it repeats indefinitely. So if it repeats forever, we need a slightly different way of doing it. But let's do the terminating first. Let's take this 0.75 and go back. I know you know the answer is 3/4, but 0.75, this is the same as 75 over 100. Dividing by 100 moves the decimal place over on the top 2 places. So it's right here, right after the 5. So moving it over 2 places goes here, here, which is exactly where we have it, right in front of the 7 over here. So 0.75 is 75 over 100. Now it's just a matter of getting this in lowest terms. So we can divide the top and the bottom. 75 is 5 times, say, 15, and 100 is 5 times 20. We can cancel that 5. 15 is 3 times 5. 20 is 4 times 5. We cancel out the 5s. And anyway, we're left with 3/4. We knew that was going to be the answer. Anyway, so if I have something like 831, oh, sorry, 0.831, this is the same as 831. We need to move the decimal over 1, 2, 3 times to get it over there. So we divide by 1,000. And now it's just a matter of seeing if the top and the bottom have any common factors, which in this case, they don't. So this is already in lowest terms, but something we need to check for. Okay, so what happens if the top and the bottom, what happens if our decimal repeats? So this is for terminating. What happens if it repeats? So for instance, what happens if I have something like 0.0, let's say 0.060, no, let's make it 0.03030303 forever. 0.03030303 forever. There's a trick to this, to changing something like this, which repeats forever, into a fraction. Here's what we do. We're going to use just a little bit of algebra here, a little bit of algebra 1. So we'll say that x is equal to this number. Then what we're going to do is multiply this by a big enough power of 10 so that everything shifts over, so that this 3 goes here, this 3 goes here, this 3 goes here, there'll be a 3 over here that goes here, and this 3 is going to go right there. So to shift this over far enough, I'm going to have to shift this over 2 decimal places. So I'm going to have to multiply by not 10, but 100. So 100x is, if I take this number and multiply it by 100, this 3, all I'm doing is taking this number and moving the decimal place over 1, 2 times. So it'll be 3.03030303 forever. All I did is took this number and multiply by 100. That just shifts it over by 2 and puts a 3 in front here. Everything else sort of goes back in place. You can see that all these 3s and all these zeros line up because I multiplied by 100. Now I'm going to subtract. 100x minus x, well, you know that's 99x. And 3.0303030303 forever minus 0.0303030303 forever. All the stuff after the decimal cancels out because all the stuff lines up. I'm just left with 3. So 99x equals 3. So x equals 3 over 99. But I think I can get that in lower terms. The top is just 3, but the bottom 99 factors is 3 times 33. I can cancel this 3 with this 3, leaving me with a 1 on the top. This is the same as the number 1 divided by 33. And if you type 1 over 33 into your calculator, you will see that you get this number, 0.03030303 going on forever. So when you have a decimal that repeats forever, you can't just do this trick up here. You have to take it and multiply it by the appropriate power of 10. I multiplied by 100 because this repeats after 2 places. If it repeated after 3 places, you'd multiply by 1,000. If it repeated after 1 place, you'd multiply by 10. If it repeated after 4 places, you'd multiply by 10,000. So however many zeros you need to get this to shift over. So it's just the period that it takes to repeat. And that gives you a way of computing this number in fraction form. That's it.